Hi, my name is Jenna Bakandi, and this is Project 1. Hi, welcome to Section 9.3. Today we'll be discussing figures in space. First, let's review some definitions. We'll first discuss planes and lines in space. A geometric plane is a flat surface that goes on indefinitely in all directions. Space is the set of all possible points. A half space is when you intersect a space with a plane, which would split up space into smaller sections. So when you're splitting up this section, this is subsequently dividing up the space. Skew lines. Skew lines are two lines that are not in the same plane. Parallel lines. Parallel lines are two lines that are in the same plane, but do not intersect. Parallel planes are two planes that do not intersect, so essentially the same thing. So if you hear parallel, these two are not going to intersect. Now we'll review two topics: line parallel to a plane and line perpendicular to a plane. Being parallel to a plane refers to a line and a plane that do not intersect. Now a line perpendicular to a plane is a line that intersects the plane at a 90-degree angle. And here you could see I've drawn a parallelogram to show you when you divide it straight down at a 90-degree angle, you can see that it's splitting it up into two parts. And that is planes and lines in space definition. Curves in space. For this chapter, we're going to go ahead and review a little bit for the curves in space parts. So we're going to go over some 3D objects and different kinds of shapes that we'll be dealing with. One, for example, is the helix. It comes down in almost like a DNA helix you'll see in biology. This will be the example of a helix, and it's subsequently sideways going down. We have a sphere, also an example of a simple closed surface. Sphere is a 3D object that has no cuts or divisions. It's also an object with no openings or holes in a simple closed surface. We can also look at solids, which are a 3D shape that contains any kind of amount of volume or surface area. This can go for cubes and other polyhedrons and other kind of polygons. A convex surface is going to be a object or 3D dimension or shape where you can drop any 2 points within the certain object or 3D shape, and neither of those points, when you connect them, they're not going to be able to go outside the shape. Now if it's not a convex surface, as you can see, like if there is a hole, or you can even think of a donut hole like we look into our notes that we read into for this chapter. If you connect any 2 points within this object, there's a possibility of those objects or those 2 points intersecting through the hole, so that would make it not a convex surface. A curve in a plane is described as a set of points that are drawn without stopping before all points are covered. Now that we've reviewed the definition of a curve, now we're going to compare and differ simple versus closed curves. A simple curve is a curve that does not cross itself. And you can see I have an example of a simple curve here. As you can see, when it does not cross itself at any point. And here I have an example of a non-simple curve because it does cross itself. And you can see that it's also not closed, which we'll go ahead and go over now. A closed curve is a curve where the beginning and end points are the same. So when you draw with your pencil and begin, you're going to end at the same point where you began that line. So that would be an example of closed curve. And this is also simple because you can see it doesn't cross itself anywhere. Here I have another example. It is closed. As you can see, it starts and ends at the same point, but it does cross itself, which means it's not a simple curve. Here you can see I have actually drawn an example. So can you tell me whether or not it is a closed curve and whether or not it is simple? From the notes we just took, you should have been able to evaluate that this is not a simple curve, as it does cross itself, and it's neither closed because it does not end at the start point. So this would be a non-simple and not closed curve. Let's review polyhedrons. A polyhedron is a three-dimensional shape or simple closed surface with flat polygonal faces, straight edges, and sharp corners, or vertices. These are classified as prisms, pyramids, and cubes. Here you can see I've given you a couple examples of what a polyhedron is, and it's also called different depending on how many faces it has. So in some cases, if it has 5 faces, it's going to be a tetra. If it has 4, it's going to be a poly, etc. Or quadro, etc. But that is a polyhedron. A polyhedron is a simple closed surface with flat polygonal faces, straight edges, and sharp corners or vertices. Pyramids. A pyramid is a simple closed surface, or polyhedron, formed by a polygon called the base, and a point not in the plane of the polygon, called its apex, or common vertex. Each base edge and the apex form a triangle, called a lateral face. And here is an example. You could see the point on the triangle of the pyramid is actually called the apex, and down here it would be the base. So that is your, and these would be your lateral faces, of course. That would be similar to each other. And it comes together to form the pyramid at the point of the tip, which is called the apex. Prisms. A prism is a simple closed surface, or polyhedron, that consists of 2 identical polygons that are in parallel planes, called the bases. The 2 identical bases and lateral faces join to create the parallelogram. As you can see, I've drawn an example. This would be a 5-sided parallelogram, which would be a prism. And if you could identify this for me, which would be one of the bases. And then these sides here, we would identify as our lateral faces. And in this case, the 2 join to form the parallelogram, which we would call a prism. Regular polyhedrons. A regular polyhedron is a solid or convex figure with all faces being congruent or identical regular polygons. So this means that they would be the same type of polygons. The same number of faces meet at each vertex. So for each of these, that means that each number of the faces are going to meet at each vertex. And you can see here I have some examples of some regular polyhedrons. We have a regular tetrahedron that is a pyramid. We have a cube, a regular octahedron, a regular dodecahedron, and a regular icosahedron. And these are some examples of regular polyhedrons. Let's review a few more definitions. Cones. A cone is a distinctive 3-dimensional figure that has a base and a curved surface pointed toward the top of the cone, called its apex. The lateral surface of the cone is generated by the line segments from the base to the apex. And here you can see I've drawn an example of a cone. A cone is going to have a right angle, and here you would see its radius. This would be its center point, and up here would be the top of the point, which would be called the apex, or also known as the vertex. Finally, let's review cylinders. A cylinder is a simple closed surface or 3-dimensional shape which has 2 parallel circular bases joined by a curved surface at a particular distance from the center point. So here you can see I've drawn an example of a cylinder. Here at its center it would be what we call it as the center point. And you can see here that I've also drawn its radius so that you can eventually, in future chapters we go over, we can calculate the distance and radius of a cylinder. So that is a cylinder. Congratulations! This sums up our short review of section 9.3, Figures in Space. Al Finn. We'll see you next time. Bye.